Good day. I am Miguel Galdones, and this is a video for my course project in CPE6204, which is basically logic circuits. And this is a simulation of a circuit which, as you can see, I have built for the word problem in the course project that was tasked for me to answer. And this circuit was based on the Boolean expression that I got from this truth table over here, which we will go back to later, and the corresponding K-map or Carnot map. And yes, this is the Boolean expression that I built my circuit, my logic circuit off of. This particularly the sum of products. F is equal to not A, not B plus AD plus BC. So as it is built over here. This is our reference, by the way. Yes, so that is it. AD, AD, and BC. So on to the Boolean table. Yes, we're gonna start the simulation. Onto the Boolean table. So over here, as you could see a while ago, the light was blue, meaning that it was on despite all of the switches being off. And in our word problem, the input range 00 to 1011 to 11 represents the months in the year from January to December. So we start with January, which obviously all of the inputs are 0 or false, and the output is 1 or true, which is the reason why our light is blue or on. Now, for February, we are the Boolean table says that we must switch on the switch for A, and the expected output or the light bulb is expected to go off. So if I do this one, it won't turn off the light bulb since this is an AND circuit. But if I turn off this one, as you can see, the bulb goes off. So this one doesn't matter, but this one does. Now let's move on. This time we are tasked to turn off the B switch for February, and the B switch, as you can see, is located below. So if I do this, well, if I turn on the B switch, my bad. If I turn on the B switch, the circuit output is still expected to be the same, so it's on. So the circuit output is expected to be on, and as you can see, the bulb is on. Now we are tasked for the month of April to turn on the switch for the A input. So do that, and yes, the expected output is 0 or off, as can be seen in the circuit. For the month of May, we are tasked to only turn on the C switch, and the output is expected to be the same. So yes, this is true. Yeah, we have validated the truth table. Now let's move on to January, February, March, April, May, June. Move on to June where both C and both A are on. So let's turn on that. Let's turn on this, and yes, the result or the output is just as expected. The bulb turns off. It is 0. Now C and B. So instead of A, let's turn on circuit B. No, switch B. And yes, it still holds true that the output of the bulb is open or on. And then yeah. Now let's turn on A again. And as you can be seen over here, the output is still the same or 1. So basically the bulb is unaffected, it stays on. Now let's go to D. Since we haven't talked much about switch or input D a while ago, let's toggle with input D. There. It is true. We have verified the truth table that with all other switches closed except for switch D or input D, the output or the bulb will turn off and in fact be 0. Now let's switch on A. This one. Now as you can see, usually I should be switching the A over here at the NOT section, but since the wires are not blue, that means it is false. And so I have to switch on this one in order to fulfill the truth table, the A switch over here, in order to fulfill the truth table for the bulb to be able to turn on, because this is a AND gate. So AND or the bulb will be positive or on. Where was I? This is A and D. So our next month is November, sorry, with D and B. This time it's B. So let's do that. And yes, the circuit is still off. The bulb does not light up. Finally, we have month 11, which is our December, and we will not go into month 12, 13, 14, 15 because these are don't care. We could call this don't care variables that do not matter since you only have 12 months in the year. So let us switch on input D, B, and A. So we have D, B, A. As you can see, yes, the bulb turns on. And that concludes my video for the proof that I am running the circuit I built on this simulator, particularly logic.ly or logically, well, the free one, because since I cannot afford the subscription. But this is proof that truth table is valid, and our Boolean expression is that our circuit is built based off the Boolean expression derived from the truth table and the K-map or the Karnaugh map, which I will pass in the submission portal. And I hope you were able to verify the validity of my Boolean map, or my Boolean expression, my K-map, and my truth table through the use of this video simulation. So, thank you for watching.